All right, welcome back to the deep dive. Today we're looking at a single piece of hardware.
And it's an interesting one.
It is. It's the DVIGear DVI-2512-AOC. It's an HDMI cable, 12.5 meters long. That costs, it costs over $300.
And right there, that price point tells you everything.
Exactly. So our mission today is to figure out why. What makes this specific cable so necessary in, professional environments that it justifies that cost? How is it shattering the limits of normal wiring?
Well, when you see a price like that, you know you've left the consumer world far behind. This is all about next-generation connectivity. We're talking active optical cable technology, or AOC.
Okay.
The whole goal here is to support these massive mission-critical data rates. We're talking up to 18 gigabits per second over distances that your standard copper cable could never, ever handle. Not without a lot of extra bulky hardware.
Well, let's be blunt. For $335, what specific problem does this solve? I mean, why not just get two cheaper copper cables and a repeater in the middle?
And that goes right to the core of the innovation here.
Yeah.
It's the hybrid design.
Hybrid.
Right. The cable isn't just optical fiber. It's a very clever mix. You've got 4 strands of what's called polyfluorinated optical fiber, or POF.
And that carries the main signal.
That carries the big stuff, the high bandwidth video. But it's paired with 6 traditional copper wires that handle the other things, like power and low-speed communication.
So the video signal itself is turned into light, shot down the fiber, and then turned back into electricity at the other end.
Precisely. Flawlessly.
And the result of using light, I mean, we know it gets you incredible distance, up to 100 meters or 328 feet, and you still get full 4K at 60 frames per second with really rich color depth.
Either 4.4.4 at 8-bit or 4.2.2 at 10-bit. No compromises.
But what's the critical, the economic reason for doing this?
It's the immunity factor.
Yeah.
That's the key. When your video signal is traveling as photons, as light, it is inherently immune to all the environmental noise around it.
So you're talking about RFI and EMI,
Yeah.
radio frequency and electromagnetic interference.
Exactly. The cable have a practically non-existent RF AMI profile. It doesn't get affected by noise, and it doesn't create any.
And that's what makes it a mandatory purchase in, say, a high-security government building.
It's all about risk. It is 100% about security and risk management. If you're running sensitive video in a data center or a military command room or on a stock trading floor, you need an absolute guarantee that nothing will corrupt that signal.
And that the signal can't be spied on.
That's the other side of it. The cable isn't radiating a signal that can be intercepted. That low EMI profile is the non-negotiable insurance policy. It's what makes it TAA compliant, which is what you need for U.S. government contracts.
Okay, so it performs perfectly, but what about getting it installed? Running cables in those kinds of places can be just brutal.
And you'd think a delicate optical cable would be a nightmare, but the engineering for the installation is phenomenal.
How so?
Well, first, it's incredibly robust, but also flexible. It has a UL CMPOF rating, so you can run it through plenum spaces, the air handling ducts and ceilings. And the minimum bend radius is just 2 millimeters.
2 millimeters. That's tiny. You'd snap a normal, thick copper HDMI cable trying to bend it that tight.
You destroy it. And they also solve the installer's biggest headache, trying to pull those big, bulky HDMI heads through a narrow pipe or conduit.
Right. I've been there. It's the worst.
Exactly. So with this cable, the HDMI docking connectors are removable.
They come off.
They do. You detach the ends,
Yeah.
and you're left with this tiny micro connector that's only about 12 by 10 millimeters wide. You pull that through the conduit, and then you just clip the proper connectors back on and secure them with a locking pin. It's genius.
Wow. And it powers itself.
It just draws the tiny bit of power it needs directly from the HDMI source. No external power brick needed. And it still handles all the critical handshakes, the DDC communication for EDI, and the HDCP content protection. It just works.
So if you're in a situation where you need total signal integrity, ultra-high resolution over a really long distance, and you're in a secure environment, this is the answer. It completely replaces all that bulky extender equipment.
Absolutely. It's the pinnacle of connectivity right now.
So that leaves you with the final thought. If this technology, using lasers and photodiodes to convert electricity to light and back again, can deliver a flawless 18 gigabits per second for the pros today, how long will it be before that kind of optical tech completely replaces copper, even for the short-run cables you use at home every day? That's the future you should be watching.